Welcome back to the Minecraft tutorial. This is going to be part 9. In this part we're going to be covering the generation, the chunk generation as we move. In the previous part we just did the loading of the level. Now we're actually going to do the fact that if we move forwards to the next chunk, it will load the one after it so that we can actually keep moving. Let's get into it. We're going to need to start off the A chunk. We're going to make two functions, and these functions are going to be well, not functions, we're going to be using custom events here. And the custom events are going to be extremely simple. All they're going to do is they're going to show or hide the chunk. And very simply, we're just going to say set actor hidden in game. And we're going to use this to say, is it visible? Is the chunk actually visible? Because once it's loaded, it will be visible by default. But once we move, we want to make sure that what's behind us isn't still loaded and still actively taking memory from the game. So to that, we will make it so that at least visibly it's not there, because we want to kind of avoid redoing this whole loading from the ground up. So we'll at least make it so that it doesn't generate, or at least doesn't cause any lag visually. So we want to right click and make a custom event, which we'll call CE. This will be show chunk. And we're going to place this right here. And it's going to set it to false. And just to help it be a bit easier, because we could use the is visible that already exists, we're just going to make a variable so we can modify it if we need as well. So is visible, we'll call it. And by default, we want to make sure that it is true, because when we create our actual chunk, it will be true. So here we're going to once again set it to visible. Now, on the other hand, if we want to hide it, so we're just going to copy this because it's the same thing. We want to do hidden, and visible is obviously false now. Then we'll say CE hide chunk. And that's pretty much all we have to do for the chunk. Now, there's one last thing we need to add, but for that we need a function inside of our game mode first. So we're just going to go and make that very quickly. So in our game mode, we want to make a function, not a custom event, a function. And we're going to call this start, or maybe restart loading is better. So what this function is going to do is, once we've finished or we show our new chunk, we want to inform it that, well, it can load the next one. So very similar to what we did here. And we're actually also going to place this, if we're not loading, we're going to place this here and say restart loading, and this will make sure that we start moving to the next chunk. And for now we don't do anything, and the reason we're not using the initial load chunk is because we need to do it slightly differently here. So we want to call this here as well, the same function, restart loading, because in the event where the chunk has already been preloaded, meaning we already have all the information, we've already added all the instances, then this doesn't get called, because this won't happen, because after we get here, we disable the tick, meaning that this functionality won't work again, so we'll never end up back here. So instead, we're going to say that we want to show the chunk, because we know it's already loaded. So right here, we will create or tell it to load the next one once it's set this one visible. Now we need to move on to the restart loading. So this is where most of the stuff is going to happen. We need to know a few things for this. So it's some things that we don't actually have yet, but that we're going to be setting up in a second. So the first thing we need to know is we need to know what chunk the player is in, because if we don't know where the player is, we don't know which kind of direction we're going to move in. And so initially what I was originally planning on doing, and what I think most people would think of from the get-go, is, well, why don't we just do the new chunk we entered, and we go through our list here with a find, and we try and say, well, if it's +3 or plus our render distance from the value that we already have, then, well, we can just load that one. But the thing is, if we do that, we end up losing a lot of computing power, and it really makes it lag a lot eventually. Right now, we only have, for instance, 9 in our map, which is quite light, or however many you have your render distance set to. I think it's a bit more than 9, I could be wrong. But the value is small, meaning it's very easy to find things. It doesn't cause much lag. But if it starts getting larger than that, when you start having 1,000 chunks, then that method won't work anymore. So to avoid that, what we're going to do instead is we're just going to do a very very simple math is we're going to save which blocks are on the edge. And every time we move, we're going to update those. That way we only ever have to search through a maximum of the edge of our render distance size, so to speak. So to that, we have some information we need to set up. And so the first thing we need to set up is we're going to need the player coordinates. So we're going to call this player chunk, because that's what it's going to be for. We want to know where the player is in the chunks. And so to do that, we're just going to use a 2D vector, which we could have used, to be fair, for a lot of things, but I don't know why I just decided to use a 3D vector. But for this, we'll just stick with the 2D one. That way it's easier. We only have X and Y. Now, with that in mind, we need a function that'll be able to tell us where the player is at all time. And we're going to use this function on the event tick so that we can check whether the player crosses to another chunk, and we'll then use that later. So the first thing we need to do is we're going to make that function. And this function is very simple. It's going to be equal to get player chunk. There we go. And it's going to be pure. It's going to return a 2D vector. And the reason we're making it return a 2D vector is because we can't just set this, because we need to make sure that we compare before we set. So that way we can actually see which chunk the player moved to. So we put this as return value. And what we're going to do is we are going to get player character. And from our player character, we need to know if it's valid, because in some situations, maybe it won't be valid. And we need to make sure that this doesn't cause the project to crash, because it's getting a reference to something that doesn't exist, which would lead to an access none. So if this is the case, is valid, we can get our player character, we can get our actor location, and with the actor location, we then need to convert it from its vector value to the blocks. So what we need to do here is we need to split this, or no, sorry, we don't need to split this. We can divide this overall by our chunk size. So I believe we have this right here, our chunk size. Plug this in here. So what this will do is it will divide our current location by 16, because that's our chunk size. And now with that, we need to do the same trick as we did before. I believe previously we did this, where we have to now split this. So we're going to break, because we only need the X and Y at the end. And what we need to do is we need to make sure that this is... Sorry, no. So we don't need to do this. What we want to do is we want to then snap this to a grid. Oh, no, sorry. It's probably safer if we actually do this as integers. That way we're sure they're actually... Because we want to make sure that these are floored. We don't just want to round them. We want to make sure it's floored. And so then with this, we can now plug this in to our return value right here. So split like this. There we go. So if we can just align this up without these two. There we go. And we'll move this a bit to the side. Now, in the event where we don't have this, get another return value. Return node, sorry. There we go. So by default, it will be 0, 0, because if we don't have the player, we'll assume that the player is going to be in 0, 0. Now, in most cases, this shouldn't happen, because what we're going to do now is we are going to say get player chunk right here, remove it. And what we want to do is on our spawn here, so once we are done and our map is loaded, we're going to save the player location. So here we get our player chunk, alt click to put a set, and we get our get player chunk and plug it in here. This will save where the player currently is once we spawn, which by default will be 0, 0, because that's where we told it to spawn. Now, the next thing we need to do is we need to have information about if the chunk, or if which chunk is on the edge. So to do that, we're going to need a few smaller functions. So we're going to work through them one by one. The first one we need is we're going to get the chunk ring, so to speak. So what does this mean? 0, 0 would be ring 0. 1 by 1, 1 minus 1, 1, 0. Those would all be ring 1, and 2 would be ring 2, etc. So we can't do this directly with a distance, because sometimes by distance it will be further than that, and we want to make sure that it's a specific ring. So we're going to make a function for that. And our function is not too complicated, but what we're going to do is we're going to say get chunk ring, that's what we'll call it. We're going to use our player location, and then we're going to have an input, which is going to be a 2D vector, which is going to be the coordinates. So we want to check where that chunk is located and relative to the player. So we're then going to simply say this minus the player chunk. And what we'll do is we will break this. And to get the maximum distance, or how to put it, to get the ring, any scenario we're in for the ring, the highest value amongst the two x and y will be the ring. So because we can have negative values, we need to make sure that we absolute this. Otherwise, we would end up with, obviously, if we have -1 and the ring, we want it to be 1, if it would say -1, 0, it would say, well, 0 is above. And that means ring 0, but that's not the case, it's -1. So we do an absolute, and then we call max, which will just determine or select the highest value of the two. And then we simply get to return this value as the return node, and that will be our value right here. Now in my project on the side, I have a +1 here, so we might have to come back if it's necessary, but I don't think it is. And one last thing, we can make this function pure right here. So compile, and on to the next function. Now the next function is this chunk on the edge? So is chunk on edge. Once again, we want coordinates. We want to know the coordinates here. And we are going to use our get chunk ring. And we're going to say if the result here is double equal to our, not our chunk size, our render distance, then we're good. That means that it is the edge. So we'll say return node, and we'll return the boolean, and that will be true. And this can be as well pure. So compile and close that. Now, so with this, now that we can tell if a block is on the edge, we need to be able to see which ones are on the edge and save those ones. So this is right here in our CE load chunk. And after having spawned it, we're going to add a sequence here. And this sequence is going to handle whether this chunk is actually on the edge. So we can't use the loading progress because we're doing it after. So what we'll do is we will simply say here, location, not that, it's get coordinates, sorry. Get chunk coordinates, and we are going to get our is chunk on edge, and we're going to have to split this, or can we say, we can just simply call right here 2D vector, and we'll take the first one, 2 vector 2D, which takes the coordinates x and y and ignores the z. And then we can just plug it straight in here, add a branch. And so what we want to do is now we need to save this actual chunk, because if it is true, then it's on the edge, so we need to know that. So we're going to put a reroute here. We're going to promote this to a variable, which we will call edge array. Now, edge array by default is going to be an array, so we want to get rid of it, right click to convert it to an array, and we will say add, like this. Now, just to test if this is working, what we're going to do is we're going to print this, and we're going to print every name that comes in. And so just to make sure that we can have time to read it, we're going to put something like 120, just to check that this is working. So for 120 seconds, we'll get to see the names. So because I would put this as exposed so that we tick here, for instance, it's visible, but because it's in the game mode, we can't really see it. So we'll just compile like this and give it a try. So there we go. So they've all loaded. And if we look, we have chunk 0. Oh, so that's 42. So chunk 0 is... Okay, so we have chunk 0. We have chunk 1. We have chunk 2, 3, 4, 5, and 6. And then we have 7. So that's correct as well. We have number 13, which we have as well. We have number 14, which is right here. Then we have number 20, which is right there as well. We have 21, which is right here. We have 27 as well. 28 is going to work just fine as well. That is 34. 35, correct as well. 41. And we have 42. And we have 43, 44, 45, 46, 47, all the way to 48. So it did indeed work. We have now correctly noticed which ones are on the outskirts. So with that, we now need to move on to the next step, which is updating those as we move through. So to do that, we need two things to add. So the first thing is we need to add our event tick. So right here, event tick is what we need. Okay, sorry. So I actually made a mistake here. Or not a mistake. It's more naming wrong. So it's more the name that I gave wrong. So for player chunk, it's not actually player chunk that we want to call this, but previous player chunk. So it can be saved the same way, but the whole point is that we can check relative to our active function here that will be looking constantly and see if they're different. So we're going to say not equal, and we can actually say not equal, yeah, probably just not equal like this, and add a slight variance just in case. And we want to say if it's different from our previous chunk, then that means that we've changed. So in that case, we want to say, well, careful, we're no longer at the same location. We need to change. We need to update the map, so to speak. So a very simple check we can do right here is just a simple print, and we'll see if this is actually printing. So this will tell us if once we move, it updates. Now, just to make sure that we can test it multiple times, we can add the print here. And here, we're going to use our set once again. And we are going to update it to our get player chunk. That way it updates, we do our changes here. And after that, we change the location. So let's compile and play. Okay, so about around, there we go. So we can see pretty much the size of our chunk. Let's go over and cross. Oh. We have an issue. So it's detecting that whenever we move, that we've changed chunk. The reason for that is because in the get player chunk right here, yeah, we're using the world space and simply dividing it by chunk, but that's not true. What we need is we need to get this into our block space. Then once it's actually converted to coordinates, we can actually do our division here. So in that case, I believe we can just detach that and convert this to a float, say 100, because that's what it's going to be anyway. And now it should work. Let's just disconnect that, line it up. Let's try this again. We still have our print just to be sure. Okay, so we have 0, 0, which is correct. The chunk is 0, 0. If we move, it doesn't matter. But if we go a certain distance, there we go. Now we're in chunk 1. Now we've actually moved over. So that's correct. We have indeed crossed from one chunk to another. Let's go over here and do the same thing. There we go. So now we're at -1. If we keep going this way, it will be 2 - 1. Okay, so it's working correctly now. Now we just need to test if the difference is doing it correctly. So I think we'll put this to 0.1. Normally it varies by 1 every time, so we should be safe. But just to be sure, we'll do this. Okay, let's give it a try. We're moving in the same chunk, doesn't seem to have any issues. If we move from one to the next, notices. If we go back, notices as well. And again, and again. Okay, so it's working. So now it knows once we change chunk, it's aware. And it only calls it once, so that's good. That's exactly what we want. So now here, we can actually tell it to load the next chunks. For this, what we need to do is we need another function. Or it could be done here, but it's easier if it's a function. So load in next... this is more like select new edges. Is probably the best way to call it. So right here, select new edges like this. And the first thing we need to do is we need to determine the difference between our previous location and our current location. So to do that, we simply want to subtract our previous player chunk from our current chunk, and we'll then promote this to a variable so that we have it saved. So local variable, this will be, we'll call it L difference. There we go. So the next step is we need to do a for each loop through our edge array, so that we know which ones are the edge, and we can then add a value to them, which will be the new chunk that we need to load. So right here, we're going to add a few reroutes, and we're then going to, I believe, promote this right here, or no. Yeah, so we'll just add another one here, and then we'll promote this to a variable we'll call old chunk. And we just want to make sure that this is valid before doing that, because if it's not valid, we can't really do much. So we'll just stop the whole logic here. If it is valid, first thing we do, we save that variable. One other thing, just before that way it is done, right here we want to call our restart loading like this. With our old chunk, we can now say get coordinates, and we'll just convert this once again to 2D so that everything is in the same units. Should have done this from the start, this is my bad. There we go. And so this is our old chunk's coordinates. So we're going to promote this here as well. Old chunk coordinates. There we go. Plug this there. And now here, we want to take the difference and add it to the current location. That way, we can remove or modify the, or sorry, no, not modify. We can tell what the next coordinates we need to load are. So to do that, we want to make a new array. So we're going to promote this to a normal variable, not a local one, and we'll call this loading coordinates. So delete this so that we can turn it into an array. Right click, drag it in here with control so that it doesn't do a set, and we'll say add to the array. There we go. Now with this, we have our list. And once we start this, our restart loading will handle actually taking this array and loading that actual chunk. But here, what we need to do is we need to also check whether the previous one, so our old coordinates, are actually still visible. Because if they're not visible, then we want to get rid of them. So for that, what we need to do is we need to make a very quick function. I don't think we'll make a function because I believe we only use it here. And it's simply to check whether we are within the range. So we're going to say get chunk ring. That way we know which layer we're on. And if it is inferior or equal to our render distance, then that means that we are within the actual render distance. So we can keep it visible. We don't want to do anything. If that's not the case here, what we want to do is we will then get a reference to our old chunk here and tell it to be hidden. So we'll say CE hide chunk. Now, one other thing is in this situation here, even if this is true, meaning we are visible, we need to check if we're still on the edge, because if we're no longer on the edge, we need to remove that element from the array. So we're going to say is chunk on edge, and if it isn't, so like this, on false, then we're going to get our edge array and say remove item, and it's going to be our old chunk right here. So on false, and obviously if we hit it, then that also means it should be removed as well, because it's no longer even visible. And that will do it for this function. Now we have to go and finish the restarting, which will actually do the final part, which is loading the next chunks. So the first thing here, even though this should never happen, we're just going to make sure, we're going to say, is this not empty? So if it's not empty, then we want to do the rest of the logic. If it is empty for whatever reason, it could happen, then we don't want to do anything, because we're going to be trying to make something that doesn't exist. Because the reason is we're not actually going to do a for each loop here, because as we saw in the past, we can't load them all at the same time. We get an infinite loop. So simply we get the reference to our 0, and this is going to be the coordinates we're going to make. So we're going to actually convert this back to a vector. So I believe we can say to vector. Yeah. So right here it's going to be 2 vectors, z is going to be 0, it doesn't matter. And we're going to promote this to, it's going to be our coordinates. Doesn't need to be all caps. Coordinates. Misspelled that. There you go. So on true, we get to set this, and we can move on. Now, the first thing, sequence right here, is here we're going to do most of our logic. But on the end, we're going to remove that element. So we'll simply say remove index 0, because that's the value we're trying to place right here. So that's the value that we will remove. And so the next thing we want to check is, do we actually need to create it, or can we simply make it visible? So to know that, we need to check whether in our map of chunks that value exists. So we're going to say find. I'm going to say our coordinates right here. I remember earlier saying, and I'll just explain this because somebody might ask. Earlier I mentioned the fact that we don't want to do this find, that it might cause some lag. So the reason this is okay and what I was talking about before wasn't, is because in this scenario we're doing it once. In the previous one we had to do a find through all of them and repeat constantly to actually check whether we could find it. But in this case that's not happening. It's just one call every time we actually load a chunk, so it's happening every few frames, so it's not all in one go, so it should be manageable even if there's a larger map size. So what we want to do here is we want to know if this is visible. So is visible, so get that, add a reroute because we're going to need a bit more, and we'll add a branch. Now if it is visible, what we're going to do is we are going to call this same function, so our restart loading, but we can't call it immediately. And the reason we can't call it immediately is in the event that another one does happen immediately after, it would consider it as an infinite loop as well. So what we have to do is we have to actually delay it. So we have to use a timer. So we're going to say set timer by event. And the event we're going to use right here, so create event, is going to be the same function. So we're looking for restart our loading. Just like that. So what we're going to do for the time is we want to actually put a hard value of 0.02, which is just slightly above the 60 frames. So 1 frame. It's just slightly above it. So we want to wait pretty much 1 frame. That's all. Now, on the other hand, if it isn't visible, we need to make it visible. So we're going to add a reroute here and another one. And this one right here will say show our chunk. Just like this. So let's actually move these down a bit further. There we go. Now, just like before, because we're adding chunks here, if this coordinate right here, and the reason we're using this is because we need a 2D one, if it is on the edge, then we need to inform it that it is now on the edge and add it to that map, or that array, sorry. So we'll add a branch here as well, and we can actually reconnect it to this, because it does need to check for this one even if it's already visible. And we will say here, sorry, no, we'll just grab our edge and we'll say add, and on true obviously we will be adding our new chunk right here. Now if this is false, because we start this scenario, if we don't actually have the coordinates already existing, then we need to create them. So we can go back to our event graph here, and we can actually just copy this. So select, no, not that one. We're looking for restart. There we go. So we can paste this here, We won't be using load in progress, obviously. We'll be using our coordinates right here. And make sure, obviously, you do the times 1600. Otherwise, we won't have the proper coordinates. And the same for our coordinates need to go right here. And there we go. So now plug this into our false. And we'll just move it slightly down so that we have enough space. And we'll do the same trick right here. We'll copy this, place it right here. And it's the same scenario as before. If this happens, we add it to the edge. If not, we ignore it. So let's do a reroute here, and we'll add another one just below it. Compile, save. And I believe that will cover everything we need to do. So let's actually give it a try. Okay, so let's see if we have, okay, so over there we should be able to see if it starts loading. So if we move a bit, we should end up in the next chunk here. And normally it should be loading. Let's have a look. So it does seem to be, it seems to have loaded one, but not anything more. So one thing I did forget, we actually do need to still actually add, we do need to add this to this map. And I'm not sure if this is the cause, but it might be. So we'll just give it a try to see if that's the reason. Just like this, plug this in. We'll move this down so it's more readable. Add another reroute as well. And the coordinates are the coordinates. Okay, so I know why this is happening, and this is a mistake I've made countless times. The reason is very simple. We're going through our loop here, and we're then getting here, and we're removing an element from that loop, meaning that the loop is deleting itself from the beginning. So that means it's cutting and missing some of the actual cube. So the problem is this loop right here, and we need to say for each loop, but in reverse, and that will solve our issue. So like this, and now the issue is gone normally. We line these up and plug our completed back into restart. We can then play, and now it should work. Okay, so let's give it a try. We'll move to the next chunk here. Now that should be enough. Normally, there we go, it's loading the next area. And so here is where the problem happens. Because if we look here, I'll show you the FPS as we play. If I go to the next chunk, we're going to get a tiny hitch here, and we're from 120, or at least I am, from 120 to about 90, which is more than acceptable. That's not a problem while it loads these new chunks, and then it goes back to 120, and the environment hasn't changed. It's moved, or it's shifted as I'm moving through the map. Now the problem is I can only allow it to have so much time to load, because making it any faster won't work, because we're already doing it at 1 tick delay. So for 60 frames, it could be more if we assume 120 on every PC, but that may not be the case. So we want to make it usable by everybody. So it's already having an interval as short as can be. So the only thing that we can change currently is we can change this right here in our event graph. We told it to only load one level at a time on 1 tick. And we can increase this, but by increasing it, we will increase obviously the lag. But the problem is kind of, there is no balance to the situation, because I will show you the problem right here. In the current situation, if I just decide to run straight forwards here, it's barely going to be able to keep up with me. Because right here, I've moved 3 chunks, and it has only loaded the next layer here. And so I can fall off the map pretty easily. And it also starts to make the kind of loading bug out. So to solve that, the only solution is to increase this. So let's say we put it to 4, which is still half of what we initially did. But now, so we'll let it load, and we'll show the example again. Okay, so let's try that again. Once again, keep an eye on the FPS because that's what we're trying to test here. So right now I changed chunk and we're kind of stuck at a 20-30 FPS and it feels laggy. But the advantage is it loads a lot quicker. I actually don't have time to, I don't believe I would have the time to move to the next chunk before it actually loads. As that's a good thing, but the problem is it's unplayable while that loads. And remember, we're currently doing this with a 3-block render distance, which is very short. If we were to increase this to 12, we wouldn't be able to handle this at all, even if we were to load 9 at a time. So for me, this is really the limits of what I could achieve with blueprints only, and for me, this was kind of the first time that I ever encountered something that I genuinely couldn't do with blueprints. This is not the last part, because in the next part I'm going to be adding the trees and the ability to do kind of pre-built structures, so to speak. So there'll be one last part, but hopefully you enjoyed the ride for this project, even if it's not exactly game ready. I hope you enjoyed this part, and I will see you in the next one. Goodbye.